Okay, we're starting these notes right now. I do have students who have this set of notes do not have these within the notes because the copier grabbed 2 pages at once and missed this page then. So if you want to write down example 8, Tom invests, and you don't have to write it down, that's up to you. Again, this is not in your notes. You would have to flip to the very back of your notes to write it down. If you just like to write part of the problem down, you can do that. But Tom invests $9,600. He invests it into 2 different categories. One, he invests at 4% interest rate. The other, he invests in a riskier market. Turned out it gave him 10%. You might ask why he did not invest it all at 10%. Well, maybe the 4% was guaranteed. Oh, you need the notes. Okay. But so we'll say the 4% was more guaranteed, and the 10% he had to take a little bit of a risk on. The total that he invested was $9,600. And he ended up with $528 of interest that he earned. How much did he invest in each place? So we're going to say that this is a category A that he invested in at 4%. And we're going to say that there's a category B invested at 10%. Everybody agree that there's 2 unknowns here? 2 variables? If you have 2 variables, you need 2 equations. If you have 3 variables, you need 3 equations. 4 variables, you need 4 equations, so on and so forth. So I have 2 variables, I need 2 equations. I'm going to write 1 equation for the total amount he invested and 1 for the amount of interest he got. What's his total investment?
$9,600.
And how much interest did he get?
$528.
So can somebody think of an equation involving A, B, and 9,600?
$9,600 equals A times 1.04 to the power of I think it's just 1 plus B times 1.1.
I like the way you're thinking. You're thinking back to our interest rate thing, yes? Mm-hmm. We can make it a little bit simpler than that, okay? Let me just try to mark it out this way. Suppose that the amount he invests at 4% is $5,000. How much did he then invest at the 10%?
$4,600.
$4,600. Everybody agree that those 2 amounts have to add up to what?
528.
9,000.
Oh, whoops, yeah.
Our first equation is very simple. The amount he invested in each total $9,600. Then we have this factor of what we call interest. He earned 4% interest on A, and he earned 10% interest on B, and that totaled $528. So we now have 2 equations with 2 variables. This is a system of equations. We have 2 ways mathematically that we solve systems of equations. What are those 2 options? One starts with an E, one starts with an S. Yep, we got elimination and substitution. What would you like to do, elimination or substitution? It's up to you. All right, let's do substitution. So I'm going to solve for B here, and I get B is equal to 9,600 minus A. Now that I know what B is, I can take it and drop it right in there. And so we have 0.04A plus 0.1 times 9,600 minus A is equal to 528. Is everybody okay with my equation? I'll distribute the 0.1, 0.04A plus 960 minus 0.1A is equal to 528. I will combine like terms. 0.04A and negative 0.1A makes negative 0.06A. If I subtract the 960 over the other side, I get negative 432. Negative 432 divided by negative 0.06. Somebody be handy with their calculator for me. 7,200 invested at A, which is 4%. How much did I then invest at 10%?
2,200.
Very good. Yep, that remaining amount, 2,400. Those both should add up to 9,600, which they do. Okay. Are we good? The next one comes straight from a chemistry class. We have two quantities. We have a quantity of 60% acid, and we have a quantity of 30% acid. And we're going to mix them together to try to come up with a 50% acidic solution that has a total amount of 300 milliliters. Okay? So let's try to think this problem through, use some common sense about what's going on. This has 60%. This has 30%. Do I know how many milliliters I have in here? No, it doesn't say at all how many milliliters there are. Does it say how many milliliters are in this one? Do I know how much I want as I dump them together?
300.
300. So maybe I'll dump 250 and 50. Maybe I'll dump 100 and 200. Who knows? But total amount I'm going to drop out is 300 combined. 300 combined. Okay? Now, if I got 30 and I got 60 and I dump an even amount out, anybody know what percentage the new solution is going to be?
45%.
45% is going to be right in between them, right? So if I want 50, am I going to have to dump more of the 60 or more of the 30?
60.
You have to dump more of the 60. Everybody see that? So I know I need to come up with 300. I know I'm going to dump more of the 60. All I've done is just thought about the problem before I actually started it to try to give me a little bit of an idea of where I'm going. Again, I've got two variables here. I got the amount that's for A, and I got the amount that's for B. I've got those two scenarios set up here, okay? And I need a total of 300 milliliters. And then I also need a certain amount of acid. Anybody come up with an equation for the total?
0.3A plus 0.6B.
Close.
A plus B.
We just want A plus B for this guy. For the acid, we want 60% of A is acid and 30% of B is acid. And that's going to give us the total amount of acid that we want. How much acid do we want?
50.5.
50 is a percentage. How much actual milliliters do we want that's acid? 150. If there's 300 total milliliters, 150 of that needs to be acid. Very, very common. Number one mistake with this problem is people will write 0.5. I want you to think of it as, everybody see how I came up with 150? Okay, we want half of that to be acid, okay? All right, so last time we used substitution. Let's use elimination in this situation, okay? Connor, do you want your A's or your B's to go away?
A's.
You want to see A's to go away, so we're going to multiply by negative 0.6. And when I do that, I get a negative 0.6A, and I get a minus 0.6B, and then negative 0.6 times 300. I'm pretty good with that. I think that's a negative 180. And I'm going to add those two things together. That's what we do with the elimination. We add them together. And when we add them together, what happens?
The A's cancel.
A's cancel, just like Connor wanted. We get 0.3b and negative 0.6b. That makes a negative 0.3b. And then 150 and negative 180. That makes negative 30. If I divide by negative 0.3, b is equal to 100. So in context of our problem, b represents the milliliters of solution that are at 30%. So it looks like we dump out 100 milliliters at 30% acid. So how many milliliters at 60% acid do we do? 200, because it must add up to 300. So those are your mixture problems. Now what we want to go to is our work problems. We got 3 problems left. This one involves painting a house. Anybody here paint a room in the last, say, 4 years? Have you painted your room since you've been? Okay, what color did you go?
Gray.
Gray. Gray. Gray. Gray is the new beige. So gray is white. So my daughter last year is her birthday. She had her birthday on Saturday. You guys didn't ask me what she did for her birthday supper. What would you want for your birthday supper? You get whatever you want.
Pork chop.
Pork chop? She went sirloin steak with Caesar salad, cheese and potatoes, and cornbread muffins with honey on top.
It's pretty good.
Then ice cream for dessert. It was a good night. We ate. It was delicious. Absolutely delicious. Last year she wanted her room painted for her birthday. And so people said, so you painted a room for her? I said, no, I bought her a can of paint. It's a good thing to learn how to paint your room, right? Yeah. These guys are painting. It takes John 32 hours to paint a house. It takes Eric 24 hours to paint a house. The question is, how long does it take them to do it together? I don't want you to answer this problem because I think it's a little bit too challenging to answer. What I would like you to do is talk to the person next to you, come up with what you feel like is a reasonable guess. We'll see who can come the closest. Okay? Reasonable guess. Talk amongst you. Reasonable guess. Go.
All right, go.
Plug a number in.
No. And then you equal out.
Probably
25.
It's like
40
45
things we have.
Yeah, so you can't guess.
No. Yeah.
Well, okay.
So we're not guessing.
No,
No,
32
no,
A,
actually, no.
C, or 24 B.
No,
it's C.
20.
And then you calculate one of those up for something.
Wait, no. What?
And then it turns into what B plus what A equals.
I think that's pushing.
Yeah.
That's not even that far off.
No creo.
That's 3 hours. Maybe they got
22 más
We're including their lunch break.
24 lo divides por 2.
So
28 horas.
You've got 30 seconds to come up with a guess.
That can be should be
No.
If it takes 1 day.
20 hours. No, 15. Is it 20?
28 hours.
You're pushing.
So if it takes
If it doesn't.
24 hours, exactly how possible. Creo que
You
8 horas.
think John's a little bit slower, so he's gonna save 4 hours?
10 seconds.
Digo que 8.
14 hours, 17's my last guess. My last guess.
3, 2, 1. Any guesses over here? Nobody wants to throw out a number?
14.
Okay, I heard 16 and I heard 14.
14. 15. 17.
Awesome game.
Well, let's just think about it. Did anybody go to 28?
Yeah.
Because that's just right between the two of them, right? It's the first thing I thought of when I saw the problem. And I thought about it. I was like, well, wait a minute. If Eric can do it himself in 24 hours, there ain't no way it's going to take more time, right? Like that's just silly nonsense. So then I thought about it and I said, well, if John could do it in 32 and let's say Eric could do it in 32 as well, let's make the problem easy. If they both could do it in 32, then how long would it take them together? Take them 16 if they were to do it together. Suppose that it took them both 24, then how long would it take them together? 12. So we got to be somewhere between there, don't we? So I think that 14 is an excellent, excellent guess. It's not right, but it's a really good guess. At the end of the day, I want to see that my answer should be between 12 and 16. Everybody got that? So here's what we do. We say that work is equal to the rate times the time. So let's use Eric for example. Eric paints one house in 24 hours. Okay? One house in 24 hours. Suppose that Eric works, so that's his rate. Let's look at his time. Let's say that he spends 480 hours painting. How many houses will he paint? 20. 20 houses. Does that make sense? Rate times time is equal to the amount of work you get done. So we're going to use that logic. We have the work of John plus the work of Eric. Who's going to do more work here, Eric or John? Eric's going to do more work, okay? How many houses do they paint? One house. That's the amount of work they want to get done. So John might be 40% of the job, and Eric might be 60% of the job. But total, there's going to be one house that they paint, okay? So I need the work. Look at this. Work is rate times time. So I need the rate of John times the amount of time it takes them together, plus the rate of Eric times the amount of time together, and that's equal to 1. What is John's rate?
One house over 32 hours.
One house every 32 hours times time, plus
One house over 24 hours times time.
times time is equal to one house that gets done. Now, as a math teacher, I really like this because I have one variable going on here. I just have t in both scenarios. And so therefore, I'm going to write this as t over 32 plus t over 24 is equal to 1. How do I solve that equation? I need to find common denominators. What number do both 32 and 24 multiply to? So the 9 ends in a 6. 96. Good, 96. So we're multiplying top and bottom by 3 to get 96. Multiply top and bottom by 4 to get 96. So on the top I'll have 3t plus 4t. 7t over 96 is equal to 1. Multiply both sides by 96. 7t is equal to 96. Divide by 7t is 13.71 hours. Somebody confirm it's 13.71, not 13.17.
It's good.
Okay, thank you.
Some blessing game.
So as we said, we should be somewhere between 12 and 16. We are. That's that.
That's in between 12 and.
Yep, right between 12 and 16, right?
Yeah.
So 14 was a good guess, but obviously it's not right. Flip it over. 2 more. Now Matt and Sue are painting houses. It takes them 5 hours if they work together. Either they're a lot faster at painting smaller houses. I'm going to say they're painting smaller houses. Okay? John makes his way back into the problem. Get out of here, John. We're going to just refer to you as Matt again. Sorry about that. Get rid of John, put Matt in there. Okay. It turns out that Matt paints the house twice as fast as Sue. Sue's not very fast. She likes to take a lot of breaks. Okay. She doesn't want to overwork herself. Okay. How long would it take Matt to paint the house alone? Well, I have the work of Matt plus the work of Sue is equal to how many houses are they painting? 1 house. Remember that work is equal to the rate times the time. The rate times the time. So we have the rate of Matt times time plus the rate of Sue times the time is equal to 1. True or false? Their rates are the same. False. True or false? The amount of time that they spend painting the house together is the same. Yeah, they're spending 5 hours, right? So we can plug in 5 for T. So we got, times 5 and times 5. So what we need is we need to fill in the rates there. And I always think that when you get confused, just start picking a number, going with it. So suppose we got Matt here. Suppose Matt does 1 house every 20 hours. What would Sue's rate be?
40.
Yeah, 1 house every 40 hours, right? Because it takes her twice as long. So if it takes Matt 1 house every H hours, then it takes Sue 1 house every 2 H hours. See how just doing like one example, think about in my head, helped me set that part up? Otherwise, I'm guessing a lot of people would put the 2H on the bottom for Matt. And so we get 5 over H plus 5 over 2H is equal to 1. Now what? Common denominators multiply top and bottom by 2. What do you get in the top? I've got 10 plus 5. This could give me a grand old 15. In the denominator, I've got 2H is equal to 1 over 1. I will cross multiply 2H is equal to 15. Divide by 2H is equal to 7.5 hours. 7.5 hours. That's how long it takes Matt. How long would it take Sue? 15 hours. Takes her twice as long. Right. Good. Last example for the day. Classic problem about 2 planes flying towards one another. We have one plane heading from the city of Los Angeles, and it is flying at a rate of 500 miles per hour. We have another plane that is flying from New York, and it is flying at a speed of 650 miles per hour. It is 2,450 miles that separate these two cities. The question is, how long have they been flying for when they meet? So how much time has gone by when they meet? Okay, I need a volunteer in this situation. Who's going to volunteer? Thank you, Brecken. Give Brecken a round of applause, everybody. Yeah. How about I need somebody else to have a timer. So if you could grab your phone or something and time us. So we got a timer over by the door. Over by the door. Nobody's going to time? Got nobody?
Yeah, Connor.
Yeah, Connor. Way to go, Big Bird.
Stopwatch.
You know what? Every time I say Big Bird, Evie laughs. Just brings a smile to her face.
It
It's
wasn't
just,
meant to be a mean thing.
she smiles, and that brings me joy, Connor. So thanks for taking one for the team. You got it?
Oh my god.
You got your stopwatch on?
I think.
Okay. So, he's going to be the plane from New York. I'm going to be the plane from Los Angeles. Okay? And when Connor says go, he's going to press start, and we are going to start walking towards each other.
Okay.
Don't run into me. Okay? There'll be punishment.
I
Okay? All right. Okay. And then when we meet, stop the watch. Okay?
Go.
So nice.
8.25.
Okay. Pause. Did we travel the same distance?
No.
Absolutely not. Who traveled further?
Greg.
He did. Did we travel at the same rate?
No.
Absolutely not. Who was going faster?
Right.
He was. Did we travel for the same amount of time?
Yes.
Yes, we did. I mean, we timed out. Same amount of time, but the other two components were completely different. Agreed? This is a distance, rate, and time problem. Does everybody see that? That's how we're going to set up. Thank you, Brecken. So we've got distance, rate, and time. We know this, that distance is equal to rate times time. Kind of like in the previous problem, the amount of work you do is equal to the rate times the time. Now, you need to memorize that equation. That equation comes up all the time. Distance equals rate times time. And what we could do is we could actually write two other equations. If we divide both sides by t, we get distance divided by time. That's equal to your rate. And you could also switch it and divide both sides by t or by r, and you get distance divided by rate is equal to time. So what I know is this, is that the time of the LA plane equals the time of the New York plane. I like to think about what variable is the same. Now, there's multiple ways of solving this, and I've taken a little bit of heat from students in the past. They say, I found an easier way. Good for you. You should always seek to do problems differently than I do it. That's absolutely fine. I have to teach everybody in order to get everybody to get this. I think that this is the best way to teach it, okay? So the times are the same. So I'm going to set up each distance over the rate and set them equal to each other. So I have a distance over the rate. The rate is 500. But I do not know the distance. And then I have the New York one. I do not know the distance, but I do know the rate. It is 650. So now I need to come up with a distance. We'll see how you guys do it, this part. I'm going to mark off that they cross right there, we'll say. What variable would you like to use for the distance of the LA plane? Great, let's use x. What distance would you like to use for the New York plane?
Y.
Yeah, I would like to use y too, but then that gives us two variables. I don't like two variables. I want one variable. So I want an x in that problem. I want something that has x.
1.3x. Right? Or am I tweaking?
Where'd you come up with 1.3?
Or wait, no, I was thinking of something else.
How about this, Ben? Since you were so bold to answer, which I appreciate, suppose that this plane traveled 1,000 miles before it reached that other plane. How would that other plane? Far would that other plane have traveled?
1450.
1450. How'd you figure that out?
Because 2,450 minus 1,000 is 1450. 2,450 minus x.
Everybody see that? If that's x. That's 2,450 minus x. Cross multiply. 500 times 2,450 is 1,225,000. Minus 500x equals 650x. I add the 500 over, I get 1,225,000 is equal to 1,150x. I divide both sides by 1,150. Can somebody get on their handy dandy calculator and tell me what 1,225,000 divided by 1,150 is?
1,065.22.
So that tells us the distance. The distance is 1,065.22. Is the question asking how far it's flown or how much time it's flown for? How much time, right? We know time is equal to distance divided by rate. So this one has a distance of 1,565.22. I have to divide it by the rate. What is the rate of this one? 500. And we get x is equal to 2.13 hours. Piece of cake upside down. Now, please look at your homework. I know you got caught up in all your homework this weekend and checked your answers because they were posted online. And you said, boy, I need some more homework problems because I am getting bored. So you are working on problems 12 through 18 at this point. 12 through 18. Now, as you work on 12 through 18, I want to warn you that problem 14 is one that you have not seen a direct example of before. And so as you get to it, you might be like, oh shoot, I don't know quite how to set this up. That is a chance in which you want to try to set something up on your own without me showing you how to do it. If you're struggling, I would like to help you, but I will not help you tomorrow. And I will not help you on Wednesday. And I will not help you on Thursday. But if by Friday you still don't know how to do it, I will help you on Friday. But I'd like you to try it. Try it multiple times. Answer key is posted online. Good job today. Should we put a secret word in the video? What is our word for the day?
NASA.
You can't just say my name every time.
I enjoy it.
NASA.
You want NASA.
Minnesota Vikings.
We are going to do NASA. We'll let Evie pick because Evie Lynn got the secret word from the last time. So NASA, maybe that's Hannah Schumacher, they'll be watching. Send me an email or see me in person and you can have a little W snack.